Good morning, good afternoon, good evening, wherever you are. Hi, I'm Jackie Lynch, and what I'm going to talk to you about today is understanding electrical power for power systems, so that when you're planning to install power systems, you know what you need to do for actual electrical power. This presentation is broken down into several different areas. We'll start off with talking about a little bit of terminology. Then we'll talk about PDUs or power distribution units and line cords, which are the actual cords that bring the power into the PDU. And then we'll discuss what you need to think about when you're architecting for power, and we'll go over a few examples. So why are we even having this conversation? Servers today are far more powerful and have more CPUs, and they draw a lot more power. And there are specific rules about how you get that power from the power distribution units, and those rules can be very, very confusing. A lot of people don't understand why you need twice as many PDUs as you need actual power that you're drawing. They also want to ask the question, well, why can't I just plan for what I actually am using versus the maximum that the server could actually draw? And that's what we're going to talk about, is planning versus what is actually being used. So this slide just talks about some of the terminology that it's helpful to understand when you're talking about electrical power. We have watts, which is a unit of power, and it's described as the current flow of an amp with voltage of 1 volt. Volts I kind of think of as similar to being water pressure in a pipe. When I think about amps, which is the measure of the total electrical current that can flow, I think about that being similar to the actual water current in the pipe. And kVA is kilovolt amps or 1000 volt amps. And that's actually the unit we use when we're trying to size our PDUs. Another term you'll hear is BTUs, or British thermal units, and that's the amount of energy needed to cool or heat a pound of water. And we typically use BTUs when we're doing things like sizing the air conditioners in the machine room that our machines are going into. There are a number of formulas that are used when you're talking about power. There are different ways to figure out watts, volts, and there's also something called a power factor. So the power factor, which you will see quoted in some of the power documents for the power servers, is actually of the 100% power that could be there, what percentage do you really get to use of that power, because you're going to lose a little bit because of circuits and latency and things like that. And for power servers, you typically get to use about 0.95 to 0.98 of whatever the wattage is that they're quoting you. And then I've got some examples here for how to calculate kVA or amps. And there's 3 links at the top that have more electrical calculation formulas than you could possibly ever want to use. When you're doing power planning, there's something called the National Electrical Code. And what that code does is it makes the rules for how PDUs are derated. So by law, if you have a 60 amp PDU, you cannot draw more than 48 amps or 9.98 kVA through that PDU. So that's what you have to plan for as a maximum for that PDU. For a 30 amp PDU, which we sometimes refer to as an L630P, it's 24 amps or 4.99 kVA. Some of them are listed as 4.8, so you need to go by whatever the listing is for that PDU. But by law, you can't actually plan to connect more things to a PDU than could draw all that power. And below I have a list of all the IBM PDUs. There are a couple of new ones that are out, but it just gives you an idea of what they have. The other thing you need to be aware of is whether they have C13 or C19 outlets, and that's because most of the servers use C13, but there are a couple, and specifically the E850 and E950, that require C19 outlets. So you need to be aware of that. And if you're using non-IBM PDUs, again, you need to know what their full amperage or kVAs is, and then what they're actually derated to. And the most common IBM line cords for your servers will be the 6492, which is an IEC 30960A, also known as a 60 amp line cord. The one that we see in most data centers is a 6654, which is an L630P, which is your 30 amp that's derated to 24 amp. This slide is just showing you for the 7188 or 9188 PDU and the various line cords what the maximum kVA is that you can draw from them. And that's what you should use for planning. It also gives you the details, for instance, of what the power load can be for each circuit breaker, because typically on these particular ones, I think it's one circuit breaker per 2 outlets. And any individual outlet is limited to 10 amps. So these are the things that you should be reading up on when you go to plan how you're going to connect things. This is an example of an IBM PDU which has the C13s, and you can see that the outlets are in pairs, and each one of those pairs has its own circuit breaker with a status LED. And then down the bottom is the big connector, and that's what the big line cord that goes to the actual power box is actually going to be connected to. We mentioned that the two most common line cords, and these are the lines that are actually going out to the circuits where you actually bring the power into the building. So we have the 6492, which is our 60 amp one that we derate to 48, and this is what the plug looks like, and there's details on here. And then we have the 6654, which is our 30 amp, and again you can see what the connectors look like. Most of the confusion is due to the way redundant power supplies work. You have redundant power on the server, and you'll have redundant power cords. So if I look at an sep2024, for example, it has 4 power supplies and 4 power cords, and they are set up as 2 redundant pairs. 2 cords will go to one PDU and 2 to a second PDU, or you can spread them around 4 PDUs. The key thing to know is that 2.38 kVA is spread across 2 of the cords. And so when you're doing your power calculations, you need to remember that it could be 2.38 on the PDU that those 2 are connected to. It could be 2.38 on the redundant one that it fails over to. And you have no control over which PDU the server draws power from. So even though you only need 2.38 kVA, you actually need to plan for either of the 2 PDUs to take that whole load. And if you don't do that and a PDU or circuit fails, you can run the risk of an outage due to overloading. And I've seen fires, I've seen I/O draws and servers just power off because there was a circuit failure and they went to draw all the power from 2 PDUs and it wasn't available. So when I use kVA and watts and BTUs for planning purposes, I use the maximums in the red books. What that does, it means that if I add cards or the server gets busy, I'm not at risk. And then when I take that kVA and I go, okay, it's 2.38, and that's on across 2 PDUs, then I make sure that I have enough extra capacity for that 2.38 on the 2 failover ports. Hopefully that makes sense to you. This is an example for that S824. So you can see down the middle, I've got the 4 power supplies, and I take 2 of them and I take them over to one PDU, and I take the other 2 to another PDU, so that I know that each PDU has to be capable of taking 2.38 kVA, even though the maximum that you will draw is 2.38. But again, if PDU 1 fails, all that load will switch over to PDU 2, and you have to have the capacity there. This is the same example, just using a Power 10 S1024. So again, it's showing you the same thing, just the amperage and kVA are a little higher. If you look in the red book, what you'll see is there will be an operating environment information section. And in this case, this is the red book for the Power 1014, 1022, 1022S, and 1024. So you can see it gives you the different wattage for the power supplies. It tells you how many BTUs an hour, it tells you what the wattages it will draw, and it gives you the kVAs for the maximum configuration. These are the numbers that I use when I'm doing my power planning. This slide is just showing you the rear of the power 10-1022, and this is the one that supports two 2000 watt power supplies. And you can see here that we have two power cords. The first power supply is the one that you're typically going to be using. The second is for redundancy. And you only need one power supply during the boot phase or for normal system operation, but you should always connect both power supplies so that you have redundancy in case of a problem. And this is the same diagram for the power 10-1024. This has four 1600 watt power supplies, and as you can see, they're in the middle, and two of them would go to one PDU, two would go to the other, and two of them are always required. The third and fourth are for redundancy, but again, you should always connect all four so that you do have full redundancy. Here we have the information for the power 10-1050, and as you can see, this draws a lot more watts. Its maximum power source loading is 5.36 kVA, and again, this one actually has four power supplies in a 2-in-2 configuration. If you look at this diagram, you'll see that the shape of the power supplies is a little bit different, and that's because these are C19s, not C13 connections. The 1050 has four 2300 watt power supplies, and they, as I said earlier, are in a 2+2 redundancy. You can actually hot plug a failed power supply unit, but if two become defective, the system will continue to run, but it may throttle it down. During boot, it requires 3 working PSUs. It will power on with only 2 of them. So again, you need to connect all 4 power supplies to make sure that things will work normally. This is the information from the power 10-10-1080 operating environment. And you can see it's 4500 watts and 4.6 kVA maximum, and it gives you those BTUs. So the 1080 has 4 1950 watt bulk power supply units, and as you can see from looking at the diagram, these are C13, C14 type receptacles, and each node draws up to 4.6 kVA. Now the 1080 also has a system control unit which has things like a DVD drive and so on in it. That actually draws its power from the system nodes, so it does not have its own power connection. Again, there's 4 power supplies, and they're in a 2+2 redundant power with dual power sources set up. On this slide, I'm trying to show you the maximum kVAs for various types of nodes and also the power cord requirements. One of the things you'll see is that the E1050, E950, and E850C are all C19 receptacles. Since most PDUs are either C13 or C19, you need to know from your actual PDU which receptacles they take. There may be a couple of them out there that actually have both, but that would be very rare. So when I look at this, if I look at an E1080, it's 4.6 kVA, and it has 4 cords. So I could take 2 power cords and put them on one PDU, and 2 power cords and put them on another PDU, still remain below the 4.9 kVA if it's a 30 amp PDU. However, if you look at the E1050, it draws more kVA than a 30 amp PDU can provide. So if you were going to stick with 30 amp PDUs, you would need 4 of them, with each cord going to a separate PDU, and then for the first pair, you would divide the 5.36 by 2, and that's what each one in the pair would be carrying. And for your redundant pair, that's what they need to be capable of carrying. So that's the kind of math that you need to do. It's one of the reasons why, as you move to Power 9 and Power 10, you should seriously consider, if you can, moving to 60 amp PDUs to reduce the number of PDUs and circuits you'll require. Because the other thing that happens is you'll put a PDU in and it'll have like 12 plugs, and you could use 2 of them. And that definitely confuses people. This example shows you some of the complexities with planning. In this case, I haven't included any storage or anything. I've simply been planning for the PDUs for the servers and the HMC and monitor. So I have a S1022, an E1050, and a single node E1080. And I pulled all the information for them from the Redbook operating environment section for each one. When you look at this setup, the total kVA required is 12.77. So if each PDU that's 30 amp can handle 4.99, then that equates to needing 3 PDUs. And for redundancy, that means you need 6 30 amp PDUs. In terms of 60 amp PDUs, they can handle 9.98 kVA, so you would need 2 for the work and then 2 for redundancy. However, that assumes that you can mix C19 and C13 connections on the PDUs. Most of them don't do that, so if you have to separate them, then your needs change. You would need 4 30 amp PDUs for the E1050s, which is 2 pair, and that's because the 1050 is 5.36 kVA, which is more than 4.99. So what you would have to do is have 2 PDUs that take one each of the 2 main power cords, and then another 2 PDUs for redundancy. So instead of the whole 5.36 being on one PDU, half of it would be on one, half would be on another, with 2 more PDUs for redundancy. Hence the 4 30 amp C19 PDUs. And then you would need another 4 30 amp C13 PDUs for the remaining E1080 HMC monitor and the 1022. Alternatively, you could replace for the C19s, you could have 2 60 amp PDUs for that. So again, these are all things that you have to look at in terms of how you plan this out. The way I keep track of all of this is I maintain a spreadsheet for all of the servers that keeps track of the kVA and the amps, and then I divide the servers by the amperage to figure out how many servers per PDU pair there should be. And this has a typo in it. That should be servers per PDU pair for 24 amps in the first column there, and then the last one is correct with the 60 amps. So you can see that for the E1080 I just need 2 PDUs, and I can have other things on there because I'm only using a certain number of kVA, a certain number of amps, but I use this to keep track of it and for doing all my planning, and I find it to be really helpful. A number of people right now are going through the transition from Power 8 straight through to Power 10. So this spreadsheet here just gives you an idea of what the Power 8 requirements were. You can then compare them to your Power 10 requirements. But don't forget that if you are planning on transitioning from the Power 8 to the Power 10 but having both there for a while, you need to provide sufficient power for both environments until you actually decommission your Power 8s. When I work with a customer on buying a new server and planning for it, I usually do a PDU layout diagram, and it just shows what I would plug in where on the server, what the plug requirements are, and so on. So in this case, I'm pretending that the PDU is a combined C13, C19, and I've just made a note of where I would plug things in. And you'll see that some of them in -1, -2, -3, -4, that's basically just keeping track of the 4 plugs, for instance, on the 1080 or the 1050, and where I would actually connect them. And you can see I track the kVA. So if you look at the E1050, you'll notice that to each plug I assign 2.68 kVA, but it's actually the 2 power cords combined are 5.36. So I've spread all 4 cords across multiple PDUs. I could have 2 of them on one PDU and 2 on another, but only if it's a 60 amp PDU. Why are we actually discussing this? It's really important that you plan for power before ordering anything, and that should be covered in what's called a TDA, or Technical Delivery Assurance. And you can do many versions of those. They're mandatory for the 1080s. They're also recommended for the 1050s, and they're usually required for First and Enterprise, although that may have changed. I do them for everything. Even if it's a site that I've worked with before and that already has Power 10s, I want to make sure that there's enough room in the rack, that there's enough power available, because it's very frustrating when the box arrives and you can't plug it in because there isn't enough power capacity. And power can take a while to order. If you happen to need new circuits, and that kind of thing. You're talking about involving electricians, and sometimes they take a couple of months. So it's important to plan for all of this before any equipment ships. Typically, when I do a TDA, there's a summary of the configuration. There's a list of items to confirm, which for me is usually is your networking copper or fiber. You know, what are the SAN cards that you really want and the speeds? What do you need in terms of transceivers? These are all things that you can solve up front. And of course, the power and cooling requirements. I usually provide reference information, a copy of the full configuration. Depending on what people need, we may talk about LPAR layouts, memory overhead. The whole purpose of a TDA, even the little mini TDA, is to avoid problems with power, rack space, Ethernet, and HBA types. And they take anywhere from really 45 to 90 minutes, but given what it can save you in time, it's well worth doing. On this slide, I just have a bunch of references. In particular, I've written a couple of articles on this that are probably going to do a much better job of explaining what I'm getting at about power. So I've given you the links to them. And if you have any trouble finding them, you can always drop me a note. I've also given you links to power formulas and also to power cord details. There's a company called Quail, as well as the IBM documents that actually have a lot of information on the various power cords and PDUs. And then, of course, to the electrical calculators. I hope you found this presentation useful and that it's helped to make things about power a little bit less confusing. I have a link here for the handout. There is actually a PDF version of this that you can go and download if you would like to. Otherwise, I want to thank you for listening and I want to wish you all the best. Have a wonderful week. Thank you.